Hello everyone, welcome to the video editorial of round 877 of Codeforces. This was a division 2 contest and I am Haricharan. So let's start with problem A. So if you look at problem A, the problem is called Blackboard List. You can pause the video and look at the problem. Right. So the idea is we are initially starting off with two integers. Let's call this integers, let's say x and y, right? So x and y are initially written on the blackboard. Notice that x and y can be positive, negative, or they can be 0 also. Now what we are doing is we keep writing all the absolute value of the differences. So let's say we are writing absolute value of x minus y. In fact, I'll just use the mod here. We might have the absolute value of x minus y minus y, for instance, and then we might have absolute value of x minus y minus x, etc., etc. Right? So we have various options like this. But what is a very interesting thing to note? The interesting thing to note is that all of these things are positive, or they can be 0 also. So that means if the initial two numbers are negative, even if the initial two numbers are negative, every single absolute difference we obtain after that will be positive. And that's very interesting because in the question they are asking us only to output one of the initial numbers and not both of the initial numbers, and that's very nice for us. So that's the thing we'll be utilizing here. So our idea will be to sort the array, where our array is all the numbers written on the blackboard. So you can just sort the array. After that, what will we going to do? We'll do the following thing. If A0 is negative, then that means it's always a correct answer. Why? So A0 is the smallest element of A, and that has to be an initial element. Like basically, if one of the elements of the array is negative, then that can be and has to be one of the initial elements of the array. So if A0 is negative, we can just close our eyes and blindly output A0. So that is always fine, right? Right. By the way, when does this occur? This occurs when one or both x and y are positive. Or negative. Now, one more case might be, so the other case is both x and y are positive, right? If both x and y are positive, what will happen? Well, the thing is, since we are taking the absolute values of all the differences, so what are we doing here? Let's assume for simplicity x is greater than y. So our entire list will look something like x, y, x minus y, etc., etc., right? So the point I am trying to make here is that when we subtract a bunch of positive numbers, we will always end up with numbers that are smaller than the initial numbers, or it can be 0 also. But the point I am trying to make here is that the numbers we started off initially with, they have to be the biggest numbers in the set. So that means my solution has to be like basically the biggest number of the set is a valid solution. So basically I can just output a n minus 1 in this case. I can quickly show you my code also. So I have a bunch of template stuff here, you don't have to bother about that. So basically I'm just like taking in n here, I'm just taking in the entire vector also. Va is my macro for a vector of integers. So then I'm just sorting my array. If the smallest element is negative, I can output that, it's always fine. The other case will be both my initial elements are positive. So in that case, I can output the largest element of the array. And that's it for problem A. Okay, now let's continue with problem B. So here we are given a permutation P, and I mean you can read through the question if you want. Now they are asking us to minimize the number of subarrays that will be permutations. So let's see how we can achieve that. So this will be problem B, right? So let's see how we can solve this problem. So the first thing I'm going to make a claim is that we can always take the corresponding subarrays. Like basically a couple of subarrays will always be permutations. What are those? So like let's say I have some permutation like 2, 3, 1, 5, 4. The subarray containing 1, that is always permutation, and the entire thing, that is the entire array itself, that is also a permutation. So these two are always permutations. So the minimum number of permutations will be 2. The question is it possible that like we don't have any more permutations at all. And turns out the answer is yes, it is possible to create, it is possible to swap indices in such a way that we don't have any more permutations. And we'll see how we can do that. This might be easier if I show you my code. So basically what we are doing here is the following thing. So we are looking at the index where 1 occurs, right? So I'll call that index ind1 for now. We're looking at the index where 2 occurs. I'll call that ind2, and the index at which the maximum number occurs, that's, in this case it's 5, right? So I'll call it maxInd. So we have these three variables, int1, int2 and maxInd. For the above array, int1 will be 3, int2 will be 1 and maxInd will be 4 if I am one indexing it. Now based on this, let's proceed. Now there are 6 different possibilities, and we can have a look at all of those 6 possibilities. But before that, I think it will be easier if I just paste this thing here. Okay, right. So we have these 6 possibilities, right? Now, like this is just simple permutation thing. So we have 3 things, int1, int2 and maxInd, all of them are different. So there are of course 3 factorial or 6 ways to arrange them, and we'll just have a blind look at all 6 of the possibilities and see what happens, right? The first possibility is int is smaller than maxInd and maxInd is smaller than int2. So this basically means you have something like 1, n, 2, in between you have something, and here also you have something, right? Now this is a very desirable form. Why is this a very desirable form? Because whenever I include 2, I will definitely include n, and that cannot be a permutation. So what is my aim here? My aim is to create the following format. If I am able to create the format 1n2 or 2n1, and in between there can be anything else, we don't bother about that. If I am able to create the following formats, one very interesting thing will happen. That is, if I try to include 2, whenever I try to include the number 2, the number n will be included, and like if I take 1 something in between n, something in between and 2, that won't be a permutation unless I choose the entire array. That's the thing we're going for here. We're trying to generate 1 n2 and we're trying to generate 2 n1. So in the first case, it's of the form 1 and 2 already, so we just output 0, 0. Actually I 0 indexed my array, so it's a bit weird. Also this print function is my own function which I defined just to output the corresponding indices. Okay, let's look at the next case. The next case actually it's of the form 1, 2 and n. Now 1, 2 and n is very undesirable, so instead what do? Well, we just swap these two. That's why I'm printing ind2 and maxInd, because we can just swap one, like we can just swap 2 and n to obtain the form 1 and 2. Third case also is something pretty similar. So here it's of the form n, 1 and 2. In this case we can swap, again we can swap like these two indices to get 1 and 2, 1 n 2, and even in the fourth case it's something very similar, but it's the reversed case of the above. So this case will be of the form int is greater than maxInd, so it will be like 2 and 1. 2 and 1 is fine, so we don't do anything. In the next case it will be actually int is greater than int2, so it will be like, no, this has to be, wait, give me a second. Yeah, this is 2 and 1 only. So in this case it should be like 1, 2 n. So this format is 1, 2 n, and we don't want that, so we just swap these two. So it will be of the form 2 and 1, and in the final case it's actually of the form like it's the only permutation that's left over. So it has to be, let's think about this, it has to be 2 1 n, right? Yeah, so it has to be 2 1 and n, and in this case we just swap maxInd and n, so we just swap these two, right? And that will be my final solution. So if you look through my code, that's basically everything in my code. Apart from that, I defined my own print function just to output those indices properly, and that's it for this problem. So let's move on to the problem C. You can of course pause the video and you can read the question. So what is our aim here? Well, our aim is to generate an uh, especially a grid that is of size n by m, and the differences of adjacent cells has to be a prime number, and keep in mind that 1 is not considered to be a prime number in this particular case. Okay, so let's see how we can do problem C. So in doing problem C, the fact that 1 is not a prime number is actually very interesting, right? So let's have a look at the worst case where m is prime and n is also prime. Both are prime, okay? Now let's think about a very simplistic solution. Let's take the example where I just simply try to write down everything all the way up to m, right? So there are m columns in my array, so I just write numbers from 1 all the way up to m, and then here I will write m plus 1 all the way up to like 2m, etc, etc. Like this I'll keep doing until I reach n minus 1 times m plus 1, and here I'll be reaching n times m, right? So I hope this is clear. So this is my entire array, okay? Now this is already pretty nice. Why is this pretty nice? Because these differences are 1, 1, 1, etc, and those are actually not primes. So 1 is not prime. So basically the differences between elements along a particular row is completely fine, but the differences between elements in a particular column, that is not fine, because here m plus 1 minus 1, m plus 1 minus 1 equals m, and that is prime. Now that's certainly very bad, right? But let's think of a simple solution for this. Let's see if it's possible to swap some of the rows. So we will try to interchange some of the rows such that like if we interchange some of the rows, then this problem might not occur. So we will try to do that here. So here I have numbers from 1 all the way up to n minus 1 times n plus 1. So that means basically what will be these differences here? So whatever differences we have here, that will be some k times m, where k belongs to 1 all the way up to n minus 1. So like basically these differences will be of the form m, 2m, 3m, 4m, etc, etc. Now if the differences is of the form m, it's not fine because m is prime, but difference of the form 2m, 3m, 4m, etc are very fine. So we'll be utilizing this here. So if n is equal to 1, right? So we're saying differences of the form 2m, 3m, 4m is fine. So let's start with the case where n equals 4. If n is equal to 4, like what array can we generate? So I'll quickly look through my solution for this. Yeah. So the array we can generate will be actually 2, 4, 1, 3. So I'll just take an example in which m equals 4, or rather m equals 5, and we'll see how to solve this. So m equals 5 and n is equal to 4, right? So we'll see how we can solve this. So if m was equal to 5, the first row we have to write numbers of the form, like it has to be basically 2 minus 1 times m plus 1, okay? And of course obviously the next few elements will be fine only. They will be 2 minus 1 times m plus 2, etc, etc, right? And here I will have 4 minus 1 times m plus 1, etc, etc, and here I will have basically 1 minus 1 times m plus 1, and here I will have 3 minus 1 times m plus 1. So if you were to quickly write down the entire array, of course I won't write the full array, but I'll just give you a gist of it. In this particular case, that would have been basically it will be 6, 7, 8, 9, 10, and then it will be 16, 17, 18, 19, 20. It will be 1, 2, 3, 4, 5, and then it will be 11, 12, 13, 14, 15. If you look at the differences between adjacent rows, here it's actually 10, here it's equal to 15, and here also it's equal to equal 10. 10 is 5 times 2, this is 5 times 3, this is also 5 times 2. So basically, even though 5 was a prime number, by virtue of adding this 2, 3, 2, we actually have a composite number, and a composite number is very good. So if n equals 4, we will cover that case. If n equals 5, what do we want to do? So I will first write down all the numbers 1, 2, 3, 4, 5, and we'll rephrase the problem. So basically, the same way I chose this set here, I want to choose my correct set. So how will I choose my set? Well, my set is pretty easy to choose. I just want to have a difference greater than 1 at all times. Like, because here if you look at this, the differences between adjacent elements was greater than 1. So the differences between adjacent elements is greater than 1. Like, so if I arrange my rows in that order, then it will be excellent, and that's what I'll try to achieve here. So I can always do one thing. So what is that one thing? Well, I can always take the first element, the middle element, the last element, right? After that, what I will try to do is I will try to go through these elements in forward and these elements in reverse. So this is actually true for all odd indices. So if let's say n equals 9, for instance, I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. Then actually what I can do is my final array would be 1, 5, 9, and then I'll take one from forward and one from reverse. So I took 1, 5, and 9 already. So I took one from forward, that's 2. I take one from reverse, that's 8. One from forward, 3. One from reverse, 7. One from forward, 4, and one from reverse, 6. And so this will be my final array. And if you look at this, the differences between adjacent element is greater than 2. That's the property we are utilizing. Now if n is even, it's actually even more easier. If n is even, it will be greater than 4 obviously, so it has to be greater than or equal to 6 basically. If we take the case where n equal to 6, it's very easy actually. I just have to match up this element, this element, this element, this element, this element, and this element. So I just have to match up, so my sequence will be like I plus n over 2, I plus 1, I plus 1 plus n over 2, etc., etc. Right? So that's how I will generate my array. So in this case, my array would have been 1, 4, 2, 5, 3, 6. And you can see that the differences between adjacent elements, they are like this. Right? I hope that's clear. So I will just show my code also. So SS is this array I've been describing here. So SS depends only on n here. So this array I've boxed here and I've boxed it here also. That array I've called SS in my case. So if n equals 4, I just hard coded the value of SS here. If n is an even number, same thing I told, I just take I and I plus n over 2. If n is odd, then I do this thing I told you about, where I take the first element, the middle element, the last element, and then I start taking from the reverse and add from the other reverse also. So I hope that's clear. Right, so now that I have defined my array SS, all of my array elements are actually very easy. They will just be SSI times m plus j plus 1. We are doing j plus 1 because j runs from 0 to m, so we are just doing j plus 1. So I hope that's clear. And in then I am just printing everything. So I hope this problem is clear. Okay, moving on to problem D. You can pause the question and like read through the problem. I think it's a very nice question. Okay. In this I got it wrong many times because of a small error I was making, but after that I rectified it and I got it correct. So let's have a look at the solution. So basically, what is the important thing to note here? Well, the first thing, let me get one thing straight. So in a query, what are we doing? Well, the thing is, in a query we just flipping like one of the elements of the sequence basically, right? So we're just flipping a left bracket to be a right bracket or a right bracket to be a left bracket. So let's look at a case where n is odd. Now if n is odd, there is something very interesting, right? So let's say n was 5, right? If n was 5, the interesting thing to note is that I am trying to reach from the first to the last, right? So so I can go like this, I can go like this. Now I might retrace my step and go back and then come forward again and then go like this. But the important thing to note is that every time I go back, in order to reach the last cell, I have to come back again. Like if I go back once, I have to come forward once. And that's something very important to note, because since n is odd, the total number of elements in RBS will be odd always. It will be odd because if I have something like this, let's say, right? If I have something like this, I can do this, I can retrace and go back, I can go forward again, and then I will do this index, right? So this will be 1, 2, 3, 4, 5. In that case, my RBS was something like this. The point I am trying to make here is we'll always have an odd number of total elements in my sequence. Actually, it's not an RBS but a sequence, right? And that's very bad, because every time we have an odd number of elements in a sequence, it can never be an RBS. So if n is odd, the answer is no always, right? Now let's look at the case where n is even. So if n is even, let's think about what we can do. So like I'll take this example here because that will make my life easier. So if I take this example, this is my initial RBS, right? Now what's an important thing to note? So I'll keep track of all the indices where this structure occurs. So a left bracket occurs. So I'll throw this in a set called left. Now indices where right brackets occur, that is called set right. Right? So we have these two sets here, one is called left and one is called right. So let's make a couple of cases here, right? So when is my sequence and an RBS, or I can, so I mean the thing itself might not be an RBS, but I can make it into an RBS. So let's think about that, right? So first thing is, if I have something like this, then it's definitely an RBS, no issues in that. Now if I have something like this, okay, now this thing by itself is definitely not an RBS, but is there such a walk such that I get an RBS? That's the important question, right? And turns out the answer is yes. The reason is I can just keep retracing my path through these two like these two left brackets here as long as I want. So how much ever I want, I can just retrace my path through both of the left indices till it becomes an RBS. So that is always valid. So I can do something like this again. So I'll just keep doing. So like I'll first go to I'll start here. So my first element will be like this, then I'll go here, then it will be like this, then I'll go back, it will be like this, then I'll go front, it will be like this. I can do it a few more times if I want, but I don't have to do that in this case. Then I just go forward. So in that case it will just be like this, and this is definitely RBS, right? So like what is the important thing to note here? Well, the important thing to note is that the first time that this structure occurs, that index has to be before the first time this structure occurs. Now why is that very important? Well, that's because we can have something like this. If you look at this RBS, everything before this is completely fine. That's because it's an RBS already, so it's not a problem. So we don't have to bother about it. But the index at which this occurs is before this, so we are completely fine. Now there is one more case also. What is that case? It's the essentially the analog of this, that basically the first time this occurs has to be before the first time this occurs, but likewise the last time this occurs has to be before the last time this occurs, right? So basically the last time two left brackets occurs has to be before the last time two right brackets occur, and that's very interesting. So again, because of the same reason, so what is the example of an invalid case? Invalid cases, if you have something like this, so I'll add this also for good measure, right? So in this structure you can never create an RBS. Actually, why is that? Because how many ever times I walk through this, it doesn't matter, because till this part it won't be an RBS. Like it won't be an RBS for the first like 4 elements. This won't be an RBS, so I can never create one more RBS from this, right? So this example is invalid. Now in implementation we have to look at a couple of things. So if you have something like this structure, it's always valid, right? So if I have this open close open close open close structure, that's always valid. But one more structure that's invalid is this. Right. Now, if I have only left brackets, right? Like only left bracket in the sense only left bracket pairs. Like I have adjacent only left brackets. Everything else is just open and closed like this. So in this case, I have two indices in which there are open left brackets, like this index and this index also. So in this case, it will definitely be invalid. Why is that? Because there will be an unbalanced number of left openings. Like every time two left brackets occur, it can't be compensated by two right brackets, and you can't generate it also. So it doesn't help you in any way. So this is definitely invalid. So basically, if right dot size is 0, then it's invalid, right? By analogy, if left dot size is 0, then also it's invalid. So we have covered those two cases here. Now let's look at so that's about all the cases I mentioned. So we just have a look at my implementation here. Okay, not the tutorial, but rather my implementation. Okay, right. So again, I have some of template stuff. We don't have to bother about that. I'm just taking in n. I'm just taking in q. I'm taking the initial string also. So the thing to notice about these queries is that every time I change one of the elements in the RBS, I can recompute my set S. So like if I do a query, right? So if I do a query, what will happen? Let's say one of the indices might change. For instance, this index might change to this maybe, right? So every time I do a query, a particular index might change, but I can recalculate my set in O of one time. That's the O of log n time. So I can recalculate everything in my set in O of log n time, because I just have to delete the previous element if there was anything, and I just have to append the new, like the new pairs, basically the new indices if valid. So, right. So first of all, I'm initially calculating my sets left and right here. So I'm just iterating over all indices from 0 to n minus 1, and if it's of this form, then I'm adding it to left. If it's of this form, I'm adding it to right. So that's the first thing. Now again, I'm just taking one of the queries here. If n is an odd number, it's always a no, as I explained at first itself. Now what am I doing? Well, I'm doing left dot erase x and left dot erase x minus 1. Why am I doing that? Well, x is the index at which I'm flipping this, right? So let's say I have something like this and something else. I don't bother about this. So let's say this was the index x. Okay, if this was the index x, first of all, what I'm doing is I'm just getting rid of this RBS, like the RBS corresponding to these two indices, and the RBS correspond sorry, not RBS, left bracket pair corresponding to these two indices and the left bracket pair corresponding to these two indices. So I'm always getting rid of it. Now that might not be a left bracket pair already. So for instance, if I have something like this, let's say, then it wouldn't have been a left bracket pair initially, but even that's completely fine. It's not a big deal. Whatever it is, if it's there in the set, I'm erasing it. If it's not there in the set also, it doesn't matter. I can still erase it. So that's what I'm doing here. So I'm getting rid of it from the left and from the right also. So if Sx is this thing, I'm just flipping it. So that's what this code does. Now I know when to insert it, right? So if it's of the form left, then I can insert it to my array left. Now this corresponds to the case. So actually there are two possible RBS which might form. So initially, let's say my initial sequence is looking like this. Let's say for instance, I chose this index, right? So if I chose this index, what will happen? Well, what will happen is that this will get flipped basically. So I'll get something like this. So now there are two left bracket sequences formed. So I'm checking if both of these are left bracket sequences. If either of them are left bracket sequences, I'm just inserting that into my set left. Likewise, I can do for my set right also. That's completely fine. So that's what I'm doing here. So I've just recalculated my set here. Now my set is fine. Now if my set is fine, do I know what to do? That's the next question. Well, if my set is fine, I know what to do. So now this is the first edge case, right? First edge case is if my sequence starts with a right bracket, my answer is always wrong. So I'll just output no. If my sequence ends at a left bracket, then also it's wrong. I'll just output no. So actually that covers this case I told you about. Yeah, so it covers this case basically. So it covers this case I have marked right now. Because you're starting with a right bracket, that's always invalid. So I'm just outputting that here. That thing is covered up. Now, what is this case? Well, this case is this. So basically, in this case, we can see that left dot size is 0 and right dot size is 0. If left dot size is 0 and right dot size is 0, and it starts with basically an opening left bracket. So if you look at this, basically for both of these cases which I have boxed, you can observe that for both of them, left dot size is 0 and right dot size is 0. But actually what is different? The first case it starts off with the left bracket, but the second case it starts off with a right bracket. So that's what we are checking in both of these two cases here. After that is the case I mentioned in which left dot size is 0 or right dot size is 0, but both of them are not simultaneously 0. Then I am outputting no, right? After that is the case I told you about in which left dot begin is less than right dot begin and left dot r begin. That's actually the left dot end basically. It's the last element of left that has to be smaller than the last element of right. Both of these are satisfied. Then I'm outputting yes. Otherwise I'm outputting no. And that's it for this problem. So I felt this contest was very nice. It was really balanced. So based on this we have concluded. So I hope you enjoyed the video tutorial and you learned a lot. So ensure that you subscribe to this channel and press the bell icon in order to obtain notifications. If you have any queries, you can post it in the comment section. Thank you.